space within 25 years. Our initial calculation said this would be up for 66 years. And we knew we'd have trouble getting an exemption for it because we're not all that important on the scale of what goes into space. This tail, by increasing the drag, the calculation said it would come down to 22 years, and that was good enough. So that's a neat thing that one of our grad students whipped up in a couple of weeks when we realized we needed to address that. These are the two antennas named Mustard and Ketchup. Don't ask me why. At Santa Clara University. They're about 3 meters in diameter, so they're not all that big. And these talk to the S-band antenna from space, both controlling the spacecraft and getting the data down. There's a little bit of pointing that's necessary so that this antenna is generally facing towards these antennas. If it were pointing exactly in the opposite direction, you'd never be able to close the radio link. And that's done with magnetic rods that are inside the spacecraft. So there are a series of magnetic rods that point along the long axis of the spacecraft, and they cause it, when it's over the northern hemisphere, to point the end with the radio antenna towards the north magnetic pole. And that keeps the patch antenna pointed generally in the vicinity of this antenna, which is at about 38 degrees latitude in the San Francisco Bay Area, so that we can talk to it. That's kind of a cool attitude control that takes no power and keeps the satellite pointed the right way, as long as you don't put the magnets in backwards. So in space where this satellite was deployed, up at 650 kilometers, 72 degrees inclination basically means it's orbiting between the Arctic and Antarctic circles, roughly. If you superimpose the orbit on the Earth, it doesn't quite go over the poles, but it kind of goes like this. And as it's doing that, it actually gets to regions where the magnetic field's not very strong. You know, the magnetic field of a